Yeah, hello. We have some minutes, yeah?
Hi, Tomasz.
Tomasz,
Can I introduce the talk by Очередной, okay? And then you will...
Okay, of course.
And then you will continue with session 3. I will explain, okay? I have wrote into the chat.
But we start after 2 minutes, yeah?
Yeah.
Okay.
I have wrote a message to the chat.
Okay, no problem. Yeah. Teraz mi znikło wszystko. No. Pomóc mi. No chyba, już pojawiło się, dobrze. No co jest? Czekajcie chwileczkę, bo się tu wyłączy ten głos.
Dear colleagues, it's time to start. Let me introduce the first speaker at the afternoon session, Alexander Очередной, his presentation with Tobias Lauer. This talk was planned to session 2, but Alexander is now at the site he will talk about, and it was planned that he will show us the section online, and he needed time to clean the section and so on. But weather and some other interesting circumstances did not allow him to do it, so he will explain himself. Alexander, take on.
Okay, thank you very much. Can you hear me?
Yes.
Yes, we hear you. Okay.
Thank you very much for this wonderful possibility to take part in this conference. I am very glad to do it, and I would like to introduce preliminary results of dating of Sukhaya Mechetka, one of the key sites for Middle Paleolithic of the Eastern and Central Europe. As Andrei Valerievich told already, we should demonstrate we would like before to demonstrate our excavations now, and because we are in the field now, and I'm talking with you from Volgograd, because Sukhaya Mechetka is situated in Volgograd, but unfortunately by one accident it is absolutely impossible, because we found yesterday an aircraft bomb. Here is it, and here you can see it is near 55 or 60 centimeters. Of course, police came immediately, and now our work was moved to another place, and we prepare one more section for Sukhaya Mechetka. I am sure it would be wonderful for the site only. So unfortunately, I can not demonstrate to you the typical site of Sukhaya Mechetka, naturally, let's say, online. But anyway, I would like to start from the little preview. So Sukhaya Mechetka here is the number 6. It is the site inside the very big number of the Middle Paleolithic site of Eastern Europe, and here you can see the sites with chronological information we have for it. For example, this map demonstrated the sites with the C14 information. But from the other hand, we have a little problem with Middle Paleolithic. You know, the Sukhaya Mechotka before some years ago, let's say, was the last Mekokian site on the east part of the east part of the Eastern Europe. Mekokian is the very interesting part of Middle Paleolithic industries. It is absolutely archaeological division, of course, and Mekokian based on the demonstrated of bifacial tools. Yes, the bifacial tools is the main typical tools for Mekokian, and Mekokian associated with Neanderthals traditionally, of course, with classical Neanderthals. So this site are very good known for the Europe, of course, for the Central, Western, and Eastern Europe. But 2 years ago, in the Altai Mountains, in Chagirskaya cave, it is very famous site now, also were found Mekokian industries. So in between Altai and Sukhaya Mechotka, we have now very big lack of Mekokian industries. But this lack deals with stratified sites. We have a lot of industries with bifacial tools, but unfortunately for northern Kazakhstan, for example, but unfortunately it is not stratified. It is material without stratification. So Sukhaya Mechotka is a very important site for us, for archaeologists, for Paleolithic. And it's situated on the northern outskirts of Volgograd city. Here you can see in the round circle, it is the right bank of the Volga, in between Volgograd Lake, let's say, and Volga River. Oh, sorry. Here you can see these bifacial asymmetric knives, which is fossil director, let's say, for Kalmesa group. And Kalmesa group is the same name for Mekokian. And this Volgograd type Kalmesa, which was divided by Gerhard Basinski, firstly, is one of the very famous tools for Mekokian, let's say, for Mekokian industries. So you can see Sukhaya Mechotka tools in the upper part of the picture. And for example, one of the tools with the same morphology from northern Kazakhstan, Shahbagata site, yes, without stratigraphy. It is the material from the unstratified material, let's say, yes. The same situation with, so inside these Mekokian tool types, yes, we have different variants of this Kalmesa, yes. And one of it, for example, it is quite possible to deal Sukhaya Mechotka and other sites with Central Europe, with Lichtenberg, for example. Here you can see photo by our colleague Marcel Weiss from the Lichtenberg with wonderful Lichtenberg Kalmesa, which is very typical for this Mekokian. And Shahbagata from Kazakhstan, northern Kazakhstan, is the same. So it is the same variant. Don't talk a lot about it. So Sukhaya Mechotka situated in the on the right bank of very wide ravine or gully on the northern part of Volgograd. Here you can see the top plan of it. And it was found by and started to excavate by Sergei Zamyatnin in the middle of 20th century. And then Nikolai Praslov, one of our researchers, one of our Paleolithic specialists, also worked there. He in the 16th and 17th. So we have a lot of information from Sukhaya Mechotka archaeologically, yes. Here you can see the losing the overlying sediments, because Sukhaya Mechotka is famous by the deepness of cultural layer. So it is the single component site, and the cultural layer lies under the 23 meters of overlying deposits. So it is one of the deeper, I think, one of the most deep Middle Paleolithic site and Paleolithic site in the world, I think. So just to have the possibility to work with it, Sergei Zamyatnin should explore the overlying deposits. And it is a view to this place where he worked after 20 years, photo by Praslov. It is the same. So here is our work, and we try to understand where the area examined by Zamyatnin located. And now all the western part of the eastern part of the site now covered by parking, which was built in 18th, and we can work now only with the western part of the site, but it's absolutely complete and no problem to work here now. Here you can see the topography of Sukhaya Mechotka with little ravine which divide this site into parts, eastern part and western part. And here are the sections which was made later by Nikolai Praslov. So Nikolai Praslov made here 6 sections and had the very interesting picture with more than 25 strata, which all of these strata deal with transgression and regression of Caspian Sea. And the connection of this strata with Volga River is it is a question. Have we this connection or not? Because the Volga River deposition we cannot find here yet. So we start to work with this place, with this site at 2014, and start to prepare the section in the lowermost part of the bottom of the lowermost part of the bank of the gully, of the right bank of the gully, and find stratigraphy with some buried soils. And the 10th strata here, this very good looking buried soil, full of charcoals associated with cultural layer. Here you can see our finds from this level. In this trench, in our trench, we found some buried cells, not only the main one, let's say, yes, associated with cultural layer, but in the overlying sediments, we had also the number of paleosols, as had Zamyatin, as had Praslov, the same. And we found there also bones, and one of it bone was associated with our specialist with Rangifer tarandis, which is very interesting for us. But the main variant of the main kind of animal here in this site is bison priscus, traditionally. Bison priscus, mammoth, and horse. So we found this paleosol full of charcoals, and we took some of these charcoals for C14 analysis. I will talk about it later a little bit. Then we prepare the section, the whole section, to understand the stratigraphy of this place. And here you can see the stratigraphy, the whole archive, I think, for this place of Caspian transgression and progression. We cannot say now, it is in a progress, let's say, because we are going on with the site now. We cannot say now that we find here something from the Volga River, let's say, yes, some deposition connected with Volga. I think maybe we will find it. I don't know. But maybe the lowermost part of the section with buried soils, maybe it connected with it could be connected with Volga sediments, but I don't know really now. In the uppermost part of this section, you can see here, you can see Khvalinian sediments. Then the border in between Khvalinian and Attalian loams, very hard Attalian loams, and somewhere here maybe the border in between Attalian loams and sediments with buried soils, which could be like, which maybe have a only localities position, only local position. Sorry, excuse me, on which could have only local position. So we cannot connect this buried soil actually with the buried soil from Plakars, and it is a problem for Sukhaya Mechetka for the moment. We try firstly. Here, sorry. In the lowermost part of our section, we found also the border in between Khazarian sands. Here is it, Khazarian sands, and these loams with paleosols, and directly on the upper part of Khazarian sands, we found this wonderful pelvic bone of bison priscus. Here is the position of it, absolutely horizontally. It is our first. Information about Sukhaya Mechetka chronology. I think it is not true. I think we have a little problem with C14 here because we did it in humic acid, and I don't think it is I don't think these days could work for the chronology of the site. But it was the first step for our team to work with chronology. The second step was to work with the help of MPI team, leading of Tobias Lauer, to try to do here the number of OSL dating, and we took 8 OSL samples. We took it with tubes firstly, and here you can see our results, which Tobias sent to us. Maybe Tobias will take 1 minute later and tell something about it a little bit. I don't know, but here we can see these ages, OSL ages. So when we put these ages to the profile, we will have this situation. Very good situation for the bottom part and a little inversion for the upper part. We really don't know why here we find this inversion. Maybe it could be deal with transgression of Caspian Sea. Maybe we doesn't know it yet, and it is also in progress. So we're in the field to do it. And so Sukhaya Michotka took part some years ago in Lost Fest, and it was a little discussion at the site. And of course, I think the future for chronology of Sukhaya Michotka, of course, to continue the OSL dating. We need a series of OSL dating. So thank you very much. It is all I can say now about Sukhaya Michotka chronostratigraphy.
Thank you, Alexander, also for keeping time. Unfortunately, we have no time for questions, and I pass the rules to Tomasz to convene next session 3.
Okay, thank you very much.
Thank you, Sasha. Thank you.
Thank you for speaker. And now we continue the first session, and will be the presentation of Margarita Gouveia.
Hello.
Hello.
Саша, нужно
I don't know if you can see me.
завершить презентацию. Ага.
Yes. I'm going to share my presentation. Okay. I
Okay,
think you can see.
Okay, now we see.
Hi.
Yeah, yes.
Good afternoon. My name is Margarida Gouveia, and I'm going to present the correlation between the fluvial staircases of the lower Tejo River and the marine terrace staircase adjacent to the river mouth in the westernmost Iberia. This research is focused on the characterization of the relative sea level change and the active tectonics in the western Iberian margin. The goals are the correlation between the fluvial and marine terraces of the same basin, based on geomorphological position and age control, understanding the relevance of the eostasy, tectonics, and climates on marine and fluvial terraces, and estimate the uplift rates in the western Iberian margin. The study area is located in the western Atlantic coast. We study the marine terraces at Raso Cape here, at the west of Lisbon, and in the Special Cape at the southern part in the west suitable. And the fluvial terraces that we study was in the reach 4 of the lower Tejo River Valley, in the more distal area, more proximal from these marine terraces, and where the fluvial terraces are best preserved. So the methodology that we used was detailed geomorphological mapping. These mapping were done based upon LIDAR surveys and MDT in order to we could identify each marine terrace levels. We used the lithostratigraphic and sedimentological analysis. As you can see here, it was the field work. Field work we consist in collect sediment sampling for dating according to the ESR protocol. For the equivalent dose measurements, the sample were collected in a fresh exposed surface. We use metal tubes sealed with foil at each end to prevent light exposure, and in special we take blocks of cement sediments. We also collect additional fluvial sediment for the sedimentological and textural analysis that was done in the lab. The geochronology methodology used here is the ESR, electrospin resonance dating method, that we use in marine terraces in the Raso and in special capes, and in T1 and T3 fluvial terraces of the lower Tejo Valley. For that, we prepare the mineral fractions in accordance with the standard procedure. We use the multiple aliquot additive dose approach, and for the equivalent dose determination, we use the two centers, the two paramagnetic centers of the quartz, aluminium and titanium lithium. And each series was measured at low temperature in the mini-H in Paris. The results, we first, here we have a detailed geomorphological map of the Raso Cape. As you can see in here, we have the Cascais platform that is a flat platform, and above that we have the 4 marine terraces that we identified and they are already in the literature. And we see the TM1 is just observed in some small patches here at the north. The TM2 is the only one that we could until now date because it had a good thickness available for dating. And the other ones are just coastal platforms without sediments possible for dates. This is a schematic section of our marine staircase. The sedimentary sequence of the TM2 comprises lower gravels at the base and coarse to middle sands here in the middle part, covered by a colluvium. We dated the one sample, the Abanus 6, and we obtained 2 reliable or accurate ages in both centers with 460 to 433,000 years. Here we think that probably the TM2 can be considered occupied by the marine isotopic stage 11 and first the 13, and after reoccupied by the 11. In this context of lower uplift rate. In special, you can see here how it is special. It's a very beautiful place, and we have another many staircases represented in here in the geomorphological map. This is an area composed by Jurassic limestone substratum and covered by the sedimentary Pliocene unit and by Pleistocene sediments along the coast. We can observe a large platform that have alien sands at the northern part, and in the eastern part we can see and are well preserved several terraces, marine terraces, especially in these areas that Chão dos Navegantes, Forte da Baralha, and in the Santa Margarida and Figueira Brava caves. We study in this part, in the promontory. This area don't have developed terrace levels, but there are cemented beach sands with some shell fragments, gravels, cross stratification at different altitudes, and were available for dating. This area has historical seismicity and have evidences of possible tectonic activity during the Quaternary. So the schematic section of this area, we see that the Special Cape rises higher than the Raso Cape, has the culminant wave cut platform called UBS 13 at 180 meters to more than 120. It has a marine terrace staircase composed by 11 terraces. In the western side of the Cape, all these marine terraces were identified. It was estimated an uplift rate of 0.08 meters per 1,000 years. And we collected 2 samples from these middle terraces and call it Special 8 and Special 7. In TM7, we had an age that is in accordance with the stratigraphy. In Special 8, the TM5, we had an underestimate ages that we are trying to understand why. Then we pass to the fluvial system, and here we have the fluvial terraces studied of the more distal part of the Tejo, next to the capes. The Tejo, as you know, well, the Tejo River is the longest river of the Iberian Peninsula. It flows westwards from Spain to reach to Atlantic Ocean in Lisbon. In the geomorphological map of the study, there are a sequence of 6 fluvial terraces. Here we can see, and we sampled in the middle base and the top of the T3, here represented, and we try to date also the T1, the oldest one fluvial terrace in this area. Sorry, okay. Here I would like to show you that we have, in contrast with the central Spain that displays more than 20 terrace levels, here the lower Tejo basin has only 6 terrace levels with a generic relative heights that are comprised between 111 to 4 or 5 meters in the alluvial plain. Here is presented a summary of the geomorphological and sedimentological characteristics of the terrace sedimentary units. And we see that we have a larger thickness of each terrace. And we think that probably they cover large time spans than those recorded as example, in the central Spain. It may be possible that 2 or more individual terrace levels of the upper catchment will be assembled in the one fluvial catchment, in the fluvial terrace in this lower basin. Here we present some of the equivalent dose curves in aluminium, titanium, lithium centers of the samples, and some ample information as the dosimetry, the dose rate, the gamma dose, and the water content. That is very important for we know the ages. And we obtain ages when underestimated, as in special 8, and some with some problems in the fluvial terraces also. So the correlation that we like to show to you is that after this geomorphological analysis and with the ages obtained for the marine terraces, we have done a correlation between the terrace systems of the lower Tejo and the special cape that is the higher uplift in the area. And we correlate that with the relative sea level estimates during these last 1 million years. And we understood that the controls that allow its may not be the same near the coast and in the fluvial system, because here we have the sedimentation in a river could be much longer in time than in a coastal stretch, and where the prevailing factors here in the marine systems is the static level and tectonics, and of course the rocky substratum that is present, where in the rivers, in addition to tectonic and the static level, there is the discharge and the availability of sediment and the climate oscillations. Despite many uncertainties regarding the sea level rise stands for each Middle Pleistocene interglacial periods and the few ages that we obtained until the moment, it was possible to estimate the apparent regional differential uplift along the area. Here we show the Abano beach in the Raso Cape and the Special Cape. We see that at Raso Cape, the 4 terraces below the culminant wave cut platform were identified. And we, for example, for the TM2 that we dated, we could correlate with 2 high stands for the first marine isotopic stage 13, and then in the marine isotopic stage 11 with the same apparent uplift. In order that in the marine isotope stage 11, we know or we think that the sea level was 6 meters above the present one, sorry. And in special, we also have done this correlation, and we see that the upper lift is a little higher. So, as conclusion, for the moment, of course, we think that the higher number of marine terraces at special in relation with the Raso Cape can be explained by the higher uplift rates. The fluvial terraces with larger thickness could record longer intervals, and that the sedimentation phase in the downstream river may be much longer in time than in the coastal stretch, controlled by the sediment supply and the transport, the climatic oscillations, the source area uplift, and the substrates present. We need more dating with the ISR and with different we think it will be very important to confirm our results, even with different types of samples. And for now, it's it's what we have to tell you, to show you. Thank you for your attention.
Thank you very much. Thank you very much. We have a time for 1-2 questions. Yes, David, please.
Hello, thank you very much, Margarita, for an excellent presentation. And I am familiar with your study area. So I've been taking my students there for several years, although unfortunately not last year and not this next year. But hopefully in the future we'll come back. I'm going to ask you a nasty question. I'm kind of taking the Rob Westerway role in this because he's not around to ask nasty questions anymore. But it's not that nasty. I'm going to ask the reverse of a question that people have asked me over the years. I'm going to ask you whether you have any biostratigraphy to support some of your ages, especially the older ones, because I have a feeling that these ages in the Tejo have been pushed back in time with repeated reworking of the ages, and I still wonder whether they are old enough. And people have always been asking me when I erected a stratigraphy based on biostratigraphy, why didn't I have lots and lots of absolute ages? Because they don't believe the biostratigraphy unless they've got absolute ages. I slightly don't believe the absolute ages unless I have the biostratigraphy. So is that a question you can answer? How much support is there from biostratigraphy, either in the marine or in the fluvial?
Okay, we have done several work in the stratigraphy in all the areas, and it was why, for example, for the here in the special, we understood that, for example, the TM8 could not be a reliable age. So yes, we have done all this work to be sure that the data, the ages are or not in accordance with that. Yes.
Okay, thank you.
Okay, thank you very much. And the second question, Martin, please.
Thanks. Hi, Margarita. Thanks for the
Hello.
really good talk. I too am familiar with this area, and I've just kind of got a question about the one of your concluding points about the differences in the terrace levels. And isn't it as simply as between the marine terraces and the fluvial terraces and the number of levels? Isn't it simply because of the difference in bedrock strength?
Sorry, I couldn't hear very well.
Isn't the difference in the number of terrace levels between the marine, the coastal record?
I cannot hear too.
I'm unmuted. Can you hear me now?
Sorry?
No? I will put the question in the chat.
I can hear.
Okay. Is the difference in the levels simply because of the difference in strength of the bedrock geology?
I can't hear. I can't hear anything.
So can I reply?
Yeah, okay, please, Pedro. Yeah.
Yes. So in the first way, Andrew. So Martin is asking about the bedrock in the case of the coastal reaches. That is not the case because the two coastal area are made of hard limestones. What is different in this case is the special platform is more elevated, so underwent more uplift. So that is not the case. And regarding the other question, maybe I also contribute because we cannot do biostratigraphy because in the fluvial areas almost all the fossils are destroyed. In some of the lower terraces we can find some bones and the tooth, but we cannot do cannot have precise chronostratigraphy with them. And of course, in the coastal areas, we have shells, but these shells do not provide any phase control. So we can only do the same way that we are doing with POS-IR dating, with electrospin and cosmogenic dating, if we have money, funds to do that.
Okay, thank you very much. But Pedro, you heard, wants to also the question? Because I see your hand.
No, it just want to do that comment, so you can move.
Okay. Okay, thank you very much. And now, Pedro, please, it's your paper.
It's me, okay. Sharing. So are you seeing, or I have to do in the other way? Is that like that? Or should I share the, it's okay?
Good.
I see. I
Yes?
see your presentation. Yeah, I see.
Okay, or is better like this? Okay, so.
I don't know. I think that will be full screen will be better. Yeah.
Okay, so the title of this this presentation is Tectonic Reactivation of a Passive Margin Landscape. And this case study provides some insights from Quaternary River terraces. And we use the Lower Mondego River located in Western Iberia. We have here a large team of researchers from sedimentologists, from lithospin researcher, from active tectonics, and general geographers also. So regarding the setting, so as I said, Iberia corresponds to an area under compression. We are paying attention to the Western Iberian margin. So we use this area of the Mondego River, indicated with this red arrow, to decipher the long-term landscape evolution during the Quaternary, and to try to understand the control play by tectonics, geostachy, climate, and also by the resistance of the substratum. Regarding the Mondego, we selected because it's a Portuguese river, not quite long. Is running from the Estrela Mountain. So Estrela Mountain is the highest area in Portugal, in mainland Portugal, and is part of the Portuguese Central Range. Here you can see that in mainland Portugal, the areas with more altitude are located in central Portugal, mainly the Portuguese Central Range, and in the northern part of the country. Of course, you can see also that geology here in this next figure controls as an important controls of the relief that we can see. More detail about the Mondego River drainage area here presented. You can see it in a MDT and the main rivers. Of course, this presentation is only focused in the lower Mondego Valley, so more or less the area between Coimbra and Figueira da Foz. So you have here the coastal line, so that makes the transition between the onshore to the Atlantic Ocean. Here you can see a geological cross section along the river. So the river runs from the Estrela Mountain in a quite high position. And as you can see, there are several nick points or nick zones, mainly relate to major faults like these two. But when is getting to more lower position, we can see that near Coimbra, so the last 50, more or less, last 50 kilometers, it do not runs over basement, over granites in pink or metamorphic rocks here in green, but it runs over Mesozoic that comprise limestones and also sandstones, and Cenozoic sedimentary rocks. These Cenozoic are only siliciclastic. So in terms of a general evolution, we can have a transition, more or less. We can ascribe an age of about 4 million years old. We have a drainage reorganization, changing from endorheic to exorheic drainage in this basin, in this Cenozoic basin. And in this moment, that is the born of an ancestral river, the Mondego River, that was running in this orange profile, reconstruction profile, that was linked to the sea level more higher than the present one. And after that, we have more or less, as you estimate, an age of 1.8 million years. There is the onset of the fluvial incision. So what we have is the entrenchment of the valley of the main river and tributaries, and the formation of terraces staircase. So we will describe this evolution and the controls. So we have here the geologic setting of the study area. Is this square will be the study area. Also, we can identify several ridges on the study area. So 1 to 4, 1 in Coimbra, 4 in the present lower estuary. They are limited by major faults and also an important gorge. Here you can see the geology of the zone. So we have different types of lithologies, but also we have faults. Some of them are vertical faults, tri-slip, but others are just like this one. So this is the main scheme. We have a culminant unit that we can use as a general reference, and we can use also as geomorphic marks the several terrace levels that we can identify. We used electrospin resonance dating, integrate as new ages provided by this work, integrated with previous OSL ages, because you want to have a chronostratigraphic framework for the terraces of the lower Mondego Valley, in order to control the role played by each controls. So what we try to do is a characterization by geomorphology, stratigraphy, sedimentology, and numerical dating of the several terraces, fluvial ones, and also marine one, in order to provide a correlation and more integration. An example of outcrops showing the example of the terrace surface, or even the deposits in a more inland area. And now I'm already showing an example of a geomorphologic map for of each one. So you see in yellow the culminant remains of the culminant unit. So the sedimentary unit that culminates the sedimentary infill, and the several terrace from T1 to T5. T6 normally is difficult to represent it because it's almost covered by alluvium. We can have in certain areas colluvians, and of course we have the alluvium in the valley. What is interesting to note is that we have several active fault systems. You can see they have a clear active control, and they also they make a vertical displacement of the terrace in some areas. Examples of the transverse cross section of the ridge 1. So these are the normal colors for the lithological the chronostratigraphic unit. So in violet we have the Triassic, blue the Jurassic, in green the Cretaceous, and in yellow the Cenozoic. So you see in gray you have the terraces, and you can see in some places the terraces have a significant thickness. And you can also see that the terrace staircase have different elevation in the two margins of the same valley. So ridge 2 in the each upstream part, this area is quite interesting because it's an area where the alluvial plain is quite large and has quite significant subsidence, tectonic subsidence played by several fault systems. So again, a strong control by faulting. Some terraces are also vertically displaced or tilted by these faults. This is the downstream area of ridge 2. You can see here more linear configuration of the valley. We believe there is a major fault along this linear valley, that is the F2 fault. Here there is a narrowing of the alluvial plain played by this anticline, Montemoro Velho anticline, made of resistant limestones. You can see this elevation here in this photo, where is the castle, but also it continues by this hill. And on the left, you can see several transverse cross section along this valley in direction to downstream. So the same topic that in some cases is clear that there is difference in the terraces, in the elevation, in one margin to the opposite margin. Now the ridge 3. So the ridge 3 is this area where is a strong narrowing of the alluvial plain because of the Montemoro Velho hill, but mainly of this sector with quite resistant Mesozoic rocks that are tilted to southwest, but the river could cut a gorge on it. And we have the several terraces that testify this evolution. Here we have in several places still the presence of the culminant unit. And we can identify the probable location of the major faults. And finally, the geological map of ridge 4. So we have clear the terrace staircase is at higher elevation in the right margin of the Mondego, because we have a major stress that is uplifting this mountain, this coastal mountain, and we have also the presence of marine terraces here in the southern part of this map, and also on the cliffs of the Mondego Cape. So examples here of the cross-section of Reach 4, the indication of marine terraces. These terraces were previously dated. For instance, the T1 is obtained ages around 100,000, so clear marine the top 5. And I can show you here as an example a profile, a long profile of the river from Coimbra upstream to Figueira da Foz, to the mouth. This is along the left valley margin. As you can see, the remains of the terraces are more uplift in the upstream area near Coimbra than in downstream, but we can also see vertical displacement of these remains between major faults that we can identify. Most of these faults are represented in the geological cartography. So we think that we have really active tectonics controlling during the Quaternary. Here I show you the results, the data that are providing the ages, the electrospin ages that we obtain for the T2, T3, and T4 terraces. So we try to date the oldest terraces, because for the younger we had OSL ages. And here on this figure on the right, you can see the elevation of the top, the surface of each terrace, and the probable age of these topmost deposits on each reference. So we don't have an age for T1, so this age is just by extrapolation, and the age for the topmost deposits of the UBS 13, so the culminant unit, is the one obtained by Gouveia et al. 2020 by electrospin. And as I said, the topmost this surface represents, and this age represents the transition to the stage of fluvial incision. Here I can show you the paleogeographic reconstructions from the T1 here, T2, T3, T4, T5 terrace of the lower Mondego River. The T6 is not represented because we don't have enough data to do the figure. As you can see, it's very clear the entrenchment of the valley with the time. So as conclusions, we could identify 6 terrace levels, the same inset in the UBS 13. They were characterized and correlated also with the coastal terraces. I note here that that's really the same number that we identify in the lower Mondego, and we can discuss why later. So we think that the fluctuating eostatic and climatic controls are superimposed on a long-term crustal uplift. However, differential uplift is deduced between the valley sides, because we think there is a major fault along the lower Mondego Valley, but also between the 4 main ridges in which the lower Mondego Valley is subdivided by faults. And we could identify and classify these several fault systems here identified. And using the elevation of the gradation surface of the culminant unit and of the river terrace above the fluvial plain, and of course the ages that we can ascribe as the most probable for the topmost deposits, we can estimate the incision range, incision rate for each one. And as a summary, I will say that they range between 0.08 to 0.34 meters per 1,000 years. And the incision rates, and in some cases, we obtain also uplift rates if we consider the vertical displacement between the faults are increasing with the time. And here we have the main compression that we still have during the Quaternary, and thanks for your attention.
Okay, thank you very much, Pedro. Now the question, Pedro. Nobody? Okay, if not, we come to the next presentation. It will be from Brazil, Marcelo Motta.
Hello, how everybody?
Hello, hello.
Hello, it's a very pleasure to be here. Let me try to share the presentation here. I like too much, Pedro, your presentation, and I never had.
Yes, full screen, please. Okay, now is okay.
Oh, yeah.
Let's go.
So, my name is Marcelo Motta, and I am a geographer and a researcher at the Catholic University of Rio de Janeiro. It's a great pleasure to be here to present the recent publications of a research group. We are from the Morphotectus, a research group that have been conducting the researches on the geomorphological landscape evolution for over 20 years. We have been studying the Paraíba do Sul River Basin located in the southeastern plateau of Brazil, analyzing the evolution of its drainage network. I try to be succinct to convey the understanding of the process of evolution of this drainage basin that has its mouth in Atlantic Ocean on the northern coast of the Rio de Janeiro state. It's good to situate this basin in the tectonic context of the evolution of South American margin. This is the South American map with the rock shield in purple, Paleozoic sedimentaries basin in brown, and Andine ridge in green that was formed in the last 6 million years. Two major tectonic events mark the history of these rocks, as well the shape of the relief of this coastline. The first event was related to the collision of the Gondwana, Western Gondwana, about 600 million years ago, with the formation of Ribeira Belt. And this is a ductile event and compressive, was responsible for the metamorphism and the formation of this rock substrate. The result of this deformation caused by this origin is a marked foliation of the rocks in addition to vertical axis isoclinal folds. including shear zones and melonization zones. This is the aspect of some outcrops in this area, and we can see this striking foliation obviously guides the drainage network and that is curved the substrates with the main direction of the northwest orientation. But in the time, we can imagine that the convergence of this drainage network went to the depot centers of the sedimentary basin of Paraná to the west and the Congo basin at the east, because the orogeny is built. This foliation naturally oriented the drainage network nowadays. So the second event, tectonic event, is the opening of Atlantic Ocean, dated in a long process between the Upper Jurassic and the Eocene. There were several phases between the pre-rift stage, and opening indeed, that form a sequence of faults and several sets of fractures. This is the fractures in the mountains and the outcrops, and we can see the main lineation in this margin. Here is Baía de Guanabara, Guanabara Bay. It's a Rio de Janeiro site. And this is a model from oldest geologist in Brazil, Fernando Flávio de Almeida, that showed the uplifting of this continental margin and the breakup of the Rift Valley with hosts and grabens. Obviously, these events promote total drainage reorganization, maintaining the northeast orientation that follows the main foliation, but forming new structures that oriented the rivers in another direction, including a new system of grabens that designed depot centers and drainage convergences within the continental margin information. They occurs from the Curitiba Basin in Paraná at the south of Brazil to São Paulo Basin, Taubaté, Resende, Volta Redonda. They are the graben system with the recorded sediments, and in the downstream sequence, Três Rios and the Itaucara grabens, that there's no evidences of sediments. So this is the Paraíba do Sul River Basin, our study area, and we have three hosts of the Órgãos Range, Bocaina Range at the south, and Mantiqueira Range at the north. As consequence of the graben system formed by this tectonic event, we have depot centers and convergence drainage system mapped. They occur, as I said, from the Paraná state to the Rio de Janeiro. But in Paraíba do Sul River Basin, there are three of these graben areas with remaining sediments and two convergent areas without oldest recorded sediments, only quaternary evidence. They are 1, Taubaté Basin, 2, Resende Basin, 3, Volta Redonda Basin, with the same sedimentary strata dated in the same period in terms of the Eocene and Miocene. In the downstream sequence, there is a convergence of drainage and other grabens, but without mapped sedimentary records. They are Três Rios, 4, and a zone of intense convergence of drainage, and Itaucara, number 5, where it was mapped a graben by a researcher of our group, Miguel Tupinambá. In these two features, as I said, there is no eocenic sediment mapped, apparently, only quaternary deposits. I said apparent because no material was effectively mapped and dated, but new projects are coming. Well, although there are no dates, the features highlight many processes of capture and reorganization of the drainage network. These features expressed in the morphology of the slopes. We can see some pictures of the area, terraces, and the fluvial terraces too, and the direction of the drainage. And we can see the in details with the mapping. We can see the process of base level change and the redirection of the river channel. We can see this kind of features. This evidence can be seen in the final part of the drainage system with the small order drainage and the superior order of drainage. We can see this example in the vicinity of the convergence area of Três Rios. Mapping and seeing such evidence, we assume a model in which the current drainage network of Paraíba do Sul River Basin originates from a fragmented drainage system in convergence areas where the graben occurs, inherited from the Atlantic opening process and its tectonic unfolding from the late Miocene. Then the final process to achieve the current configuration involves from the complete opening of the Atlantic Ocean and a process of upstream erosion of drainage networking, overcoming the host through the tropical weathering in fractures, faults, and foliation. The drainage headwaters of each graben system receded towards the upstream convergence zone, capturing and redirecting river flows and consequently the drainage network. Thus, the current network that continues to retreat in search of São Paulo sedimentary basin and the suspended plateau of Minas Gerais. This is the supposition, the evidence that we can see some graben systems and edorheic basins, then the capture towards upstream and capturing this basin, and these three last basin, there is still sediment of the Eocene present. And we think the Paraíba do Sul River wants to capture the São Paulo basin in the next sequence. This is our model, and I thank you all for your attention, and I look forward to the new meetings.
Okay, thank you very much for very interesting talk and maybe question. Yes, Pedro, please. We can hear you.
Yes.
Okay, now.
First, I want to thank to Marcelo and Rodrigo the opportunity of the visit to visit this region, amazing area. And the main question here for this topic of reorganization of drainage is, I think, quite relevant. Is this establishment of a river, a transcontinental drainage to the Atlantic, was made only during the part of the Quaternary by regressive erosion, or by the other way, by an effect of overspill and a cascading effect, getting successively these endorheic small basins, and that the stage of fluvial incision is later. So it's my main topic of discussion.
Yeah, Pedro, it's very glad to talk to you after our field trip, a long field trip that we have here in Brazil. But this is the great question, because we don't have dating yet. We're trying to ask for projects to have money to make the dates. But we know that the last basin, there's three last basin here, and Volta Redonda, Resende, and Taubaté, the sediments were dating in Miocene. And so we know that something happened after the Miocene, but we don't know exactly if it was in Pliocene or Pleistocene or Holocene. We know that this interval between the Pliocene and Pleistocene is the great moment of this draw of the drainage system.
Thanks.
Okay, thank you very much. And now Martin, please.
Thank you.
Hi, thanks. Really interesting talk. I just listening to Pedro's comments there, and the only thing that I would have to say about overspill mechanisms is that they're a lot more difficult to explain compared to capture. So you need lake sediments with shorelines and that kind of stuff. And if it's just simply competition between two adjacent river systems, then I think capture is a much easier mechanism to explain with good evidence. I mean, obviously, Pedro's experience is Western Iberia, and we've been very careful in terms of how we've explained the different mechanisms there. So we are still open.
Yeah, Martin, thank you. I think that it's the great observation, because the tropical weathering is very strong here, and the foliation and fractures are there's weathering in the GP like 100 meters inside the rock. The weathering is working, and I think the capture is the great mechanism here.
Okay, thank you very much. Maybe next question or not, because we have Vivian from Peru is present or not? Thank you, Marcel.
Thank you all.
I don't know, next speaker about the Peru, please. Oh, yes, hello.
Hello, good morning.
Good morning, or good afternoon in our time, yeah. Okay, please, take the floor.
Okay, so first of all, I would like to apologize for not being able to attend much of the FLAG meeting over the past 2 days. Because of the time difference between Peru and Europe, almost the entirety of the FLAG program has been taking place at night here. And obviously I had to catch some sleep as well, so I haven't been able to attend much of the program. Fortunately, I'm able to to give a presentation now about what we've been doing. I've been working in Peru for a couple of years now, and
Yes. Sorry, please full screen if it's possible. Yeah.
yeah, sorry. Let me see. Yep. So we've been working on several river systems now here in Peru. We've been working in the Andes region, in the rainforest, and now we're working in the coastal desert. So we're studying a river system approximately 200 kilometers south of Lima, which is the. Sorry.
Now it's okay. Continue, please.
Yes. So we're studying a river system about 200 kilometers south of Lima, which is the Cañete River system. And we have a group of international collaborators. It's Jorge Sanjurjo from University of A Coruña, who has been doing the luminescence datings. Miluska Rosas, who's my PhD student. She's working both at my university, that is the Catholic University in Peru, and she's also working at the Catholic University in Leuven in Belgium. And the last collaborator is Veerle van Akker, also from the Catholic University in Leuven. So I would like to say something about the current state of knowledge on fluvial systems here in Peru. Then I will start to speak a bit about the characteristics of the Cañete River system. And then I will tell something about the results we obtained. I will tell something about the terrace mapping we have done, sedimentology, the stratigraphy, the luminescence ages, the profiles we created, and all the implications for the factors controlling deposition of sediment and valley incision. So fluvial systems on the Peruvian coast are poorly studied, strangely enough, because Peru is a very large country. There are many river systems that are traversing the Andes and that end up in the Pacific Ocean. Many of them have fluvial terrace records. The area is mainly desert area, so there are good outcrops available. But for some reason, almost no one is studying these fluvial systems. Over the past 15 to maybe 20 years, only one research group in Switzerland has been doing research on these fluvial systems, and they developed their theories, mostly related to climate change, of how these river systems came into being. And of course, if you have one research group that has been continuously trying to prove the same theories, there might be an interest, to also look at it from another perspective and maybe come up with different theories. So we've tried to come up with different mechanisms that might explain the formation of the fluvial terraces and the valley systems in general. There is general consensus that deposition of the fluvial sediments is linked to increased precipitation, which in turn is precession controlled. Because what the Swiss have been able to demonstrate, and I agree with them, is that there are phases of increased precipitation that almost always coincide with the positive phases of the precession cycle, in which the alluvial fans in the river valleys become very active, in which the river systems start to transport the deposit sediments. So it seems there is this link, between precession and increased precipitation. But the link is not 100% because throughout Peru we find fluvial terraces which are formed during the last glacial maximum, and the last glacial maximum is just a period in which we have a negative precession cycle, and which is characterized by a very dry environment, in which precipitation is much less than during the Holocene or a bit earlier on during the last glacial. So there is a mismatch, between the amount of precipitation and the precession cycles. So that's something we are looking into as well. There's no clear hypothesis on what controls valley incision. Several hypotheses have been put forward. the majority of them relate to climate change. But there is actually very little data, hard data, that really shows us what is actually controlling valley incision. Yeah, most hypotheses have been geared towards saying that, incision is starting when we have less sediment in transport in the system, so you have cleaner water, which enables incision of the fluvial systems. But there's no quantitative data that's actually corroborating this evidence or this supposition. And strangely enough, other factors such as tectonic uplift or sea level changes have been overlooked, which is very strange because all the river systems are situated very close to the Pacific Ocean. And obviously during the glacial phases, sea level fell, which should induce a lower base level and incision of the fluvial systems. But this has not been put forward as a hypothesis yet. In the tectonic uplift, well, we're in the Andes, with very rapid tectonic uplift. But there is general consensus that the western part of the Andes have been tectonically stable over the past 15 million years, more or less, as deformation progressively moved towards the eastern part of the Andes. However, there are areas along the Peruvian coast where uplift is certainly occurring. That is exactly the area surrounding the Nazca Ridge. The Nazca Ridge is a very important seamount on top of the Nazca Plate that's currently being subducted beneath the South American plate, and which is causing uplift of the area overlying the Nazca Ridge. And we know that because there are marine terrace records that have been dated, and we know that uplift around the Nazca Ridge is in the order of 0.5 millimeter a year. And this subduction has been going on for the past 2-3 million years. So there is certainly uplift occurring in the area, but for some reason, this has not been taken into account when we consider how the fluvial systems evolved over time. So to answer all these questions, we started to investigate the Cañete River Valley, which is located here. Lima is located here. This is the Cañete River Valley. Here we have the Nazca Ridge. So you see that the Nazca Ridge is actually very close to where the Cañete River Valley is located. And perhaps, subduction of the Nazca Ridge may be a cause for uplift in the area. It's something that we'll turn back to later on. This is the catchment area of the Cañete River Valley. The river ends at the Pacific Ocean here. It starts at around 5,000 meters of sea level. It has a longitude of about 240 kilometers. As you can see here, the river profile is convex in the upper reaches and almost straight in the middle and lower reaches, which is also an indicator, or which is classically being considered as an indicator for tectonic uplift. So here there are some photos of the area. Here we have the Cañete river floodplain. It's vegetated. It's a very wide valley. And you can see here that the hill slopes are barren because the area is receiving very little rainfall. It's basically an arid environment, as you can see here as well. Here at the background, you see a terrace level, which is the T2 terrace level, which is almost continuous throughout the valley. Here is another picture. You can see some terrace levels here at the foreground, and at the background here, you see a large alluvial fan system, which you can also see here. The area is characterized by an intermingling of alluvial fans on the one hand, and fluvial terraces on the other hand, which is also visible here in the terrace maps we made. Here's the Pacific Ocean. We distinguished 5 terrace levels with elevations here up to 180 meters above current river level. And when we go more upstream, yeah, the valley becomes narrower. Terrace levels become less, as you can see here as well. Yeah. And these black spots are the alluvial fans that we mapped. Yeah. So there is a strong occurrence of alluvial fans as well. This image shows the occurrence of the fluvial terraces from a longitudinal perspective. You can see here that the T5 level is located only close to Pacific Ocean, but not upstream. The T4 level is situated a bit more upstream, up to almost 40 kilometers upstream. The T3 level is situated up to 55 kilometers upstream. It's almost continuous. The T2 level, it's discontinuous, but it can be found along the entire 80-kilometer length of the river we investigated. And the T1 level is also continuous, up to 80 kilometers upstream. What you can also see in these images is a large nick point here, approximately at between 55 and 60 kilometers upstream. This river, this nick point will play a very important role in discussing the factors controlling scission later on. In terms of sedimentology and stratigraphy, well, these terraces are actually quite simple. Yeah, in terms of sedimentological composition, it's all clasts derived from the surrounding areas, mostly igneous rocks, because the larger part of the system is traversing granodiorites and granites. Almost all terraces are clast supported with some sand lenses, yeah, but the gravels predominate, as you can see. And here's some of the sand lenses were sampled for OSL dating, for instance, here, 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 and here. And this is a diagram of the ages we obtained. We sampled 9 places, and for each sample, we looked at 5 different luminescent signals. We know from experience that the quartz in sediments is unstable, so we cannot use quartz for OSL dating. So we had to date the feldspars, yeah, using the infrared methodology. And we looked at 5 different temperatures, because we also know from other literature that some temperatures overestimate the ages, whereas other temperatures give a more reliable result. So we compared all these results. And what you can see here is these gray bars. These gray bars basically show the overlap in the ages for the various samples. So, for instance, well, for the floodplain we only have 1 sample that gave approximately 800 years. For the T1 level, we had 2 samples, yeah, and you can see that we have an overlapping age of approximately 12 to 15,000 years for the temperatures of 110 degrees and 180 degrees. The temperature of 225 degrees almost always overestimated the ages. Yeah, so we discarded this age, the ages of this temperature. The T3 terrace we dated at 4 different places, which gave us an interval of between 20 and 30,000 years, more or less. The T4 level gave us an age of 45 to 52,000 years, more or less. And the oldest terrace we dated gave an age between 105 and 18,000 years. These are the longitudinal profiles we reconstructed based on a simple modeling in Excel. Yeah, we obtained very high fits of almost with R2s of almost 1. Yeah, so very good fits. And we modeled 2 domains. Yeah, and I have to go back a little. We divided the river in 4 domains, based on the occurrence of the terraces. Domain 1 are the uppermost 12 kilometers, and this area is situated in an extensional tectonic basin. So we expect the tectonic driver to be different here because there's active subsidence occurring. Domain 2 is the area between 12 and 55 kilometers. Domain 3 is the nick point area, and domain 4 is the area upstream of the nick point. So we modeled the longitudinal profiles for domain 1 in the extensional basin and domain 2, because we have most data for these 2 domains. And what you can see is that for domain 1 in the extensional tectonic basin, you can see that the various terrace levels, the T5 level, the T4 level, the T3 level, T2 level, and the T1 level. But sorry, I didn't model the T2 level. But all these levels show convergence with the current floodplain when we go downstream. So the terraces are not parallel to the current riverbed. If we go to domain 2, you can see that all terraces are situated more or less parallel to the riverbed. So there's a clear difference between these 2 domains. The reasons for that will be discussed a bit further on. But first, I would like to say something about the timing of sediment deposition. So again, the gray bars here, they show the age intervals of our terrace levels. And here we have terrace records of other workers, both along the coastal area, but also in the central Andes itself. And the black bars are the different terrace levels that were investigated, as well as their age here. So you can see that in almost all river systems, workers describe up to 4 terrace levels. We described 5. And you can see that the timing of the fluvial terraces is very similar all along the Peruvian Andes. Yes, so in almost all river systems, going from 6 degrees southern latitude to 16 degrees southern latitude, we have one terrace level that forms at the end of the last glacial period, between 12 and 14,000 years ago. Then there is a terrace level that forms almost always between 20 and 30,000 years. For the older terrace level, there's a large variety in ages, but you can see that this terrace level almost always forms between approximately 40,000 years and 50 to 60,000 years. And in some instances, the oldest terrace level that has been dated by other workers had an age of around the onset of the last glacial age. So you can see the spread in ages is quite large, but there's also a coincidence between our results and the results of other workers. In fact, I would argue that because we looked at the overlap in the different OSL signals, that we've been able to constrain a bit more the age intervals in which fluvial deposition occurred. So this graph demonstrates the different climate drivers and the age of the terraces, again here in the gray bars. And what you can see clearly is that in some circumstances, deposition of fluvial sedimentation occurred during positive precession cycles. For instance, here, here, here. But for the T1 and possibly T2 terrace, this is not the case. So the match between precession and fluvial deposition is not 100%. However, if we look at the occurrence of Heinrich events, then you can see that for the past 50,000 years, more or less, there is a coincidence between fluvial deposition and the occurrence of, well, Heinrich event 5, 2, 1, and the Younger Dryas. So this timing seems to be more corresponding, although I have to admit that the age interval of our OSL ages is quite broad, whereas the Heinrich events, they have a typical duration of 2,000 to 3,000 years, at least here in Peru. I know that in the North Atlantic it's shorter. What we know here from other paleoclimatic records is that the duration of these wet phases is a bit longer. Okay, so here we have a record from a speleothem record from a cave in northern Peru, and again you can see that we have positive phases of precipitation, which were tied to the Heinrich events, and which more or less correspond to the timing of fluvial deposition. Yeah. Here we have a record from another cave, which is located just in the headwaters of the Cañete River Valley. And again, you can see that the positive phases in precipitation correspond to the different Heinrich events of the North Atlantic. And here we have a record of precipitation, which was reconstructed for the Altiplano in southern Peru. And you can see that the phases of very high precipitation, here, exactly match with the deposition of the fluvial sediments of the Cañete River Valley, as well as the phases here. So there is a very good correspondence between wet phases in the Andes and the occurrence of deposition, not only in our river system, but also in all other river systems in Peru. Yeah? The final figure here shows high stands of lakes in the Peruvian Andes. And you can see that the high lake stands, they also correspond to phases of increased precipitation. They also correspond to the phases in which Heinrich events occur and the phases in which fluvial deposition occurs. So I think we have quite some evidence, you know, that fluvial deposition can potentially be related to increased precipitation, which in turn may be controlled by these Heinrich events and not by precessional cycles. So incision was a topic of debate, as I said earlier on. What we did here is compare incision rates against a sea level curve. And what we did is calculate the incision rate based on the OSL ages and the altitude of the fluvial terraces. Yeah. And what you can see is that the average incision rate over the past, let's say, 120,000 years is very high. It's approximately 1.6 millimeters a year, which is very, very high, because the highest uplift rates in entire Peru are currently occurring in the Eastern Cordillera, the Eastern Cordillera, and the Sub-Andes, which is an actively deforming fault and thrust belt. And uplift rates there are approximately 2 millimeters a year. And here we calculated incision rates of 1.6 millimeters a year, which is not very far off, despite the fact that this region in Peru should be tectonically stable. Yeah, so there's obviously something happening here. Yeah. So uplift or incision rates of 1.6 millimeters a year, yeah, since 120,000 years until the present. For the younger terraces, we calculate an incision rate of approximately 0.7 millimeters a year. For T3 and T2, we calculate incision rates of approximately 0.75, and for the T1 until the present, incision rates of 0.5 millimeter a year. So what you can see here is basically that incision rates are highest when sea level starts to fall. Yeah. And then when sea level reaches a certain semi-equilibrium, you know, because sea level here is not falling that much anymore, yeah, you can see that the incision rate of T4 is becoming much less as well in comparison with earlier on. And then when sea level starts to fall again, yeah, between approximately 40,000 years and 15,000 years, incision rate slightly increases again. And when we reach the end of the last glacial period, and when sea level actually starts to rise again, you see that incision rate drops to its lowest rate during the entire last glacial. So there is a good correspondence here between how sea level is going on and how incision rate is possibly reacting to these changes in sea level fall. Tectonic forcing. This was quite complicated because we don't have a clear driver for tectonic uplift in the area. The subduction of the Nazca Ridge, it's taking place approximately 150 kilometers south of the Cañete River Valley. And according to the literature, it is not influencing uplift of the Cañete area. Yeah, so we have no clear factor that may control tectonic uplift. So I had to dive into the literature and tie together some loose ends, connect pieces of evidence to come up with a plausible hypothesis. So this is a map from Gonzalez and Fifner, 2012, in which they looked at the stream length gradient index for a lot of fluvial systems in the Peruvian Andes. And what they found is that in the area northwest of the subducting Nazca Ridge, we have one of the highest stream length gradient indices of entire Peru, strangely enough, as you can see here. This figure here shows apatite, thorium, and helium ages, which were published by Wipf et al. In 2008. This area here is the Cañete River Valley. Yeah, so they have ages from the Cañete River Valley, and they have ages from the area where currently the Nazca Ridge is subducting. And what these authors also found is that both apatite and helium ages and apatite fission track ages become younger going away from the ridge towards the Cañete River Valley. And they interpreted this pattern because of a rejuvenation of the area north of the Nazca Ridge, which is also contradicting because it's actually the area directly above the Nazca Ridge that should be uplifting faster than the area northwest of the Nazca Ridge. So something is going on here. Yeah. Finally, I found an article of Bishop et al. Who actually investigated the crust and the upper mantle, of the area surrounding the Nazca Ridge. Yeah. And what they found is very, very interesting. Yeah. To start with, they found that the area of the Cañete River Valley here is an area which has registered a lot of strike slip related earthquakes. Yeah. Second, in their seismic tomography, they found that in this area here, there is a jump in the oceanic MOHO discontinuity of approximately 20 kilometers. And the oceanic MOHO is much shallower in the area northwest of the Nazca Ridge than on top of the Nazca Ridge. Yeah. So what these authors suggested is that basically the area surrounding the Cañete River Valley is an area where a very large strike slip corridor is forming, possibly because there is a tear fault, in the oceanic crust. Yeah. Why is that? Well, here we have the Nazca Ridge. Yeah. Here we have flat slab subduction, and possibly at the transition from the Nazca Ridge to the slab, because of the forces that are acting on the oceanic crust, the crust is tearing apart here, or the oceanic crust is tearing apart here, creating this gigantic strike slip corridor, with upwelling of magma, So these flare-ups, they may be responsible for buoyancy effects underneath the Cañete area, causing uplift. Yeah, or perhaps because of this slab there, there's less gravity pushing down on the area of the Nazca Ridge, yeah, because there's less weight of the flat slab attached to the Nazca Ridge, which also causes uplift of the Nazca Ridge and the areas immediately adjacent to the Nazca Ridge. So there are several plausible mechanisms that may explain this uplift in the area. Yeah, but I hope you agree with me that all these data found by other authors point towards an uplift in the area, which is not occurring elsewhere along the Peruvian coast. Yeah, so to conclude this presentation, we described more or less the same number of fluvial terraces in the Cañete River Valley as have been found in other fluvial systems along the Peruvian Andes, which are 4 up to 5 terraces. Yeah? The phases of deposition between our terrace record and the terrace records of other workers, they agree. But because of our OSL approach, we've been able to constrain a bit better the age interval of when deposition occurs. It seems that deposition occurs during phases of increased precipitation, which may be tied to Heinrich events, but this will always remain a matter of debate because the typical error in OSL ages is larger than the duration of Heinrich events, especially for the older Heinrich events. So it will always remain a problem to demonstrate the link between these two things. Time averaged incision rates over the past 112,000 years are approximately 1.6 millimeters a year, but this varies according to the pattern in sea level fall, because there seems to be a relation between both factors. And finally, we found evidence for tectonic anomalies underneath the Cañete River Valley, which may be caused by subduction of the Nazca Ridge, and which may explain why incision rate is so high in this area. And obviously, both tectonic uplift and sea level fall are responsible for incision. Yeah. So another part of our research also looked at disentangling these two separate effects. And what we found basically is that at least 0.5 millimeters a year of incision, yeah, could be accounted for by tectonic uplift and not sea level fall. Yeah, so this was my presentation. I think I spoke a bit longer than 15 minutes. But
yes,
anyhow.
yes, a little bit
Okay.
longer, but
yeah, thank you very much.
Anyway, maybe very short question, yeah. Maybe me, because I'm working in the Lomas de la Chay, also with the fluvial system, and I found very similar terrace 3 and 4 for looks like in your river valley. Maybe it is interesting for you that we publish it in the last geomorphology after this Belgian conference. Yeah.
Okay. Yeah, we can talk about it later on. Thank you very much.
Maybe somebody more. Yes, Anne Gues, please.
Yes, hello. I found your talk very interesting, and I'm using luminescence quite a lot. So I was wondering, was it a multi-grain or single grain measurement? And did you carry out those recovery tests to see if the temperature, which of the temperature was the best?
Yes, we did multi-grain analysis.
Okay.
And we did perform dose recovery tests.
Okay.
Yes.
I think it's interesting to look into it to see which temperature is the best. Yeah.
Okay, thank you.
Thanks.
Yes.
Yes,
Yes.
I
Thomas?
not heard
Can I
nothing,
make?
yeah?
Can I make a question?
My program.
Can I make? So I have two small questions for Willem. I think the presentation is quite nice. I never saw to present ages for several protocols in terms of post-IR. Normally, there are some tests and we make an option for the better. For instance, is the 225 or 290. And because the resulting ages are different and we have to decide which are the ages that are could be more next to the more confident on that. So it's a little difficult to see these different results for several ones. The other topic is I think if we use one of these protocols, we should select for one terrace all the ages that we obtained. I think for some intervals you cut only use the part of these samples, narrowing the band. I know that this can induce us for different interpretations in terms of the controls. And of course, if we correlate with other terraces that are dated, we should indicate the method that was used to produce those ages, because sometimes old protocols produced underestimated ages or not so good ages. And I'm saying this because we should plot the gradation interval in order to see how it links for a certain control. For instance, I like also to use the static curve. So if you put the interval, maybe the interpretation will be more fine. What do you think about this?
Okay, thank you for your questions, Pedro. Can I show the OSL curve again, please? Thomas, can you please allow me to share the presentation?
Yeah,
right now?
You can share screen if you want.
Okay. Yes, thanks. Yeah, so here we have this graph again. Well, we've been working with OSL dating in Peru for almost 7 years now. And based on our experience and also the experience from other people who carried out the OSL dating, we know that there are lots of problems with the quartz here. And we also know that the feldspars in some cases give unreliable results. Yeah? So we had to investigate which signals were best, because in the literature there are contrasting evidences of which temperature yields reliable results and which temperatures not, you know. So we opted for these 5 different temperatures in the hope that there would be some correspondence, you know. What we're doing, it's novel. It has not been done before. So we are walking on unknown road here, you know. So these results that we obtained here, we hope may serve for other workers working with OSL to improve perhaps the protocols in the near future, you know. But what we've been able to see so far, if you look at the 225 temperature, you can see that it's always overestimating all the ages, always. Whereas the 50, 110, and 180 temperatures, they give similar ages, considering the error in the ages. Yeah, so we simply opted for establishing an age interval based on the overlap in the ages and their errors. I think that's the best we could do with the data we have. I agree with Pedro that it's better to look at all the different ages and to have objective criteria, you know, for which age is best. But unfortunately, there is no literature available on this. But perhaps in the near future there will be. Regarding the other question, I believe it had to do with the sea level curve. Is it correct?
Yes, yes.
Yes. Again, PowerPoint. I do agree that it's better to calculate the age, the incision between terrace levels, for instance, between the T4 and T5 or the T4 and T3. But we had the problem here that the occurrence of terrace levels is not homogeneous throughout the area. So for instance, the T4, as you can see, we have some remnants here, some remnants here, some remnants here. If we would have calculated the interval between the T4 and the T5, and you can see the T5 is only occurring here, then we would only have obtained an incision for the area where both terraces are occurring. So basically, we would have this small area here, because it's only here that the T4 and the T5 are both occurring. And the same applies for all the other terraces we mapped. So this approach was not possible. We had to do it on basis of the occurrence of the floodplain, because the floodplain is continuous. So you can directly compare all terrace remnants with the floodplain. I hope I made myself clear.
Okay, thanks.
Okay, thank you very much.
Yeah, you're welcome.
But now I think that we must stop this discussion and or move to the general discussion, all the questions to William. Yeah, maybe I asked Andre what Andre is here or not.
Yes, I'm here. Always
Yeah,
here.
what we are doing, because in the looking at the time, we are in the after the coffee break in general
Okay,
discussion.
so maybe we skip this coffee break if nobody's tired too much, and maybe we can switch to the general discussion and then to the closure, which is also the discussion on the future activity of FLAG. What do you think?
Yeah, okay. But you will be the chair of this general discussion? Yeah?
Well, me? Maybe you?
Yeah.
Tomasz, as the
Me? Okay.
FLAG
Okay.
board chair, yeah.
Okay, we stop this detailed question, and now maybe also some question to somebody. Yeah, please. I'm waiting for a hand. Yes, David, please.
I missed out, or I missed part of what you just said, Thomas, because for me, you dropped out and then came back. I don't know if that was the case for anybody else. But
Sorry, I don't understand completely what.
I'd like to say how important I think it was to have this meeting and to thank those who've done all the hard work putting it together. I think it's been valuable and enjoyable and important for keeping the FLAG momentum going. Did I hear Andre say at the outset yesterday that there were hopes to have the Moscow meeting, the Moscow and the Volga meeting at some time, possibly next year or in the future? Andre's not nodding.
No, I'm here.
Is that the case, Andre? Are we still doing a Russian meeting if we can?
Well, I was thinking on it in the last 2 days, and what I can say, we cannot be sure that next year the pandemic situation will be better than this year. That's my concern. And well, this year we were not able to invite 4 European professors for an expedition on a mutual project, and it was completely impossible to do it in an official way. And well, I am afraid that that this situation may continue through the next year. And the matter also is that we have to announce conference and field trip in some advance. For example, in the end of this year or in January. And the main problem is unpredictability. So I think my feeling is that the situation is still far. I mean the closure of the borders and so on. The situation is far from the end, and maybe for the next year it would be more safe for us if the conference and field trip was planned somewhere in Europe. I know that Tomasz planned the next year field trip in Czech Republic. At least the Europeans will be able to participate, I hope, and maybe other people also. And in our planned Russian trip, we can postpone on the next term. I mean, in 3 years, we really want to help it because we have spent much effort already for organizing. So that's my feeling, and I also think that we have to provide a backup option. So the same online conference, if a field excursion will not be possible even in Europe. So that's what I can say. But if the community will insist, we definitely will try to do it. But I can say that it's unpredictable. The success of this thing is unpredictable because of this unstable situation. Let's discuss it. Let's discuss it then. This year we had much difficulties to make a small expedition with 3 European professors. Yeah, they entered Russia as specialists in agriculture, paying much money for it, but not an official way. But it's impossible for 30 participants of a conference next year, really.
I think we need to see, we in the Northern Hemisphere need to see how we all do during this next winter, because the winter is more difficult, I think, if only because people need to be indoors. And so things might get very much worse as the cold winter approaches. And we can't really know what it's going to be like in the field season of 2022 yet, can we? So I agree with all your skepticism there, Andre. I do think having another electronic conference like this would be a good thing if we can't return to real conferences and real field trips sooner rather than later, because we're a year behind our biannual target times, aren't we? The Flag Committee, have you discussed whether to switch back to where we should be, or to just add another 2 years now?
Probably Thomas could
Thomas or
comment.
or I can't see anybody else from the committee on here actually, can I? No.
Yeah, okay. Maybe me, because there is the question, yeah, what Andre told, yeah, there is the nobody know what will be, yeah. Therefore, it's very hard to plan something. I propose this Polish-Czech organize the meeting, yeah, and Andre with Russia, but okay, we can plan, but what will be, nobody knows. Yeah? But anything, Andre, I understand that practically it is impossible to plan the symposium in your country in the next year. Yeah,
It's unpredictable. That's my concern. So we need more predictability, and in my view, it will be more predictable if it is planned in Europe, because at least Europeans will be able to participate, because within Europe now the borders are open, and that's my feeling.
Yes, I heard you very bad, yeah, but if I understand that better, you think that it will be better in Europe, yeah, because I have a break in your heart, yeah.
Yeah. That's your proposal about the Polish-Czech trip. I think it will be.
What I told on the committee, I propose that we start from Krakow and finish in Prague, yeah, and cross the Moravian and mainly Czech, but it's not necessary. Maybe somebody now have a better proposition, yeah.
Hey, Thomas, what will be the period?
Sorry?
What will be the period for this?
And the period is normal, is the September, yeah. There is classical period for the flag meetings, yeah. Before the Polish symposium, I proposed the May, but it was not good time for the other people. Therefore, okay, we can do that in September, yeah. Next year.
Okay.
Maybe in early September, because these dates for this conference, we had many difficulties from many people. The classes.
Yeah, I told many times. Yeah, the September is very occupied period. There is not very good period for the conferences, but we can move a little bit earlier for the end of August, for example. Yeah. What do you think about this period?
I vote for.
Yes, I think people are starting to having to get teaching ready, or even teaching has begun in September. So early September is better than late September and maybe late August, but August is holiday time as well, family holidays.
Yeah, there is also not so good, yeah. Yeah, but I think that if we start from the last days of August, and it will be on the first days of September, maybe it will be better. Okay, Martin, yes, please.
Can I ask Alessandro what the status of the INCWA working groups are? My understanding was that you guys in your HEX project were coming to an end.
Sorry,
or maybe
I don't hear you.
Yeah, I can answer. The INCWA HEX Aqua project is ended 2 years ago with the last INCWA meeting in Dublin. Now there is a new focus group that is called IPEDAE. It is an acronym linking hydrology, pedology, and dust and aerosols. But in the last 2 years, as the activity of INCWA are funded if they are in person, we had some activity funded, like this meeting, we had 5,000 euros available for paying young researchers for coming, but due to this pandemic situation was not possible to use them. You can't use for other purposes except to pay young people. So this is a limit. And if you want, I can say some words about the possibility for next year to apply for this kind of fundings within the TERPRO commission in INQUA. And I will suggest to do this for this planned flag meeting in September, because for that meeting, eventually, even if it's a field activity and is a, let's say, a field trip, we can say that this is a meeting where the people is doing something in the field also, so is learning in the field for the young people also. And it's, let's say, quite easy to have some money because we didn't use the money in the last 2 years, so there is a lot of money available.
I mean, I ask more from the sheer number of meetings that we have choice to go out and participate, engage with, and you know, flag back in the day 15, 20 years ago was, you know, we were routinely getting more than 100 people coming along to these kind of meetings. So okay, this year is a little bit kind of sort of smaller, but you know, one has a sense that the numbers have shrunk in recent years. So it's just trying to kind of sort of, you know, not kind of question whether flag has a reason to be or anything like that, because it does, but you know, it would be just nicer just to have a few more people come along to these sorts of meetings. I don't know whether anybody else has any.
There's an INQUA in Rome in 2023. Is that right?
There is indeed.
Yeah.
Those involved with that will be hoping very much that
the
pandemic is largely behind us by then, because there'll
and
be.
If I can say also that next year we have also the ECFS, the International Conference on Fluvial Sedimentology, is in Garda Lake, northern Italy.
Wow.
And this summer, what was not possible. So this summer we have a online meeting with 400 people registered. Next year will be in person. It's from 10th of July to 15th of July.
So why can't flag have a really strong presence in that meeting then? That would make sense.
Yeah, can be. Some in other ICFS there were a lot of flag people. Normally it's very well represented because the subject is very overlapping. Is perfectly included and flag and vice versa.
Yeah, okay, I see, but not so bad here because I have a very bad connection now. But what I understand, there is a lot of different conferences, yeah. But it's also the possibility that, for example, if you're looking on the next spring, the beginning of the year, that will be alluvial geoarchaeology organized by me and my Polish colleagues in Poland, yeah, at the beginning of the February, yeah, because we can do, for example, that we'll meet in the different conferences and move with flag symposium to the 23, yeah, I don't know, because what do you think about this?
I think in 23 you probably ought to try and link to INQUA because we've linked to several INQUA.
Oh yeah, I did think also, yeah.
It doesn't mean you can't do something as a pre-conference or post-conference field trip and then end up or start from Rome. So it doesn't have to necessarily be right on the doorstep of INQUA. But that's something to think about.
We had a really good poster session in the last INQUA. It was a very large. It's one of the larger ones, I think. So I would certainly kind of say that we should carry on that connection with INQUA and an ICFS for sure. So my sense is that an online meeting badged as flag is probably about as good as it's going to get because of the uncertainty, and that we try and align to INQA and ICFS for more face-to-face activities as a safer way of doing it.
And that gives us possibilities in the next 2 years, doesn't it?
Yeah.
So
it keeps the momentum
start
going.
with that, and then see about flag afterwards, which hopefully will be post-pandemic. Some of us will be very old indeed by then, by the way. What about the publication side of flag?
Yeah, we planned the publication with the volume after the flag this symposium, and we talked with Martin, yeah, about the geomorphology volume, and probably we try to publish some papers in this volume, yeah, because we have the two possibility, also proposition from quaternary, yeah, but I think that geomorphology will be the best deal, yeah. And
I saw the
think
quaternary wanted funding or wanted payment for publication above.
Yeah, let me comment. Yeah, I have information from the managing editor from Quaternary. This is an open access journal, and that's why it's not free. And the proposal is that if we plan the special issue, there are two options for us. First, that we publish up to 5 papers for free, but others will be charged by €1,500. That's the price now. And the second option, they can provide a 50% discount for all papers. So 750 per paper. So that's the proposal from the quaternary.
We've got the editor-in-chief of Quaternary with us, haven't we, Jeff? Well, his video's not turned on. I don't know. I realise he's coming. I realise they've got to make a profit. They've got to make a living, but the members of FLAG are not going to be able to find that sort of money, I don't think.
No, I'm a bit embarrassed by this reply from the managing editor, and I asked for some more explanation. And I'm principally I'm against paying fees for these special issues, and we managed to have two special issues after FLAG conferences, free of charge for the authors. And I would insist to have the same proposition again for the next issue, if FLAG community should agree. But I have no guarantee, of course, but I will insist on that. So I feel a bit embarrassed with this situation at the moment.
Well, maybe we will go for geomorphology. Maybe Martin can comment on our chances to.
Yeah, so geomorphology will and has taken plenty of FLAG specials over the years. So I can't see why it wouldn't consider them again. Because I'm an editor-in-chief, I'm much more party to how we evaluate special editions now, and there are a number of editors who all need to kind of vote and give it the thumbs up, the approval. It's much better if in the proposal that you have a list of potential papers that people are going to offer. It's much safer to have people who are going to be the guest special editors who have some experience. They don't necessarily have to have done a geomorphology special edition, but they can be some degree of special edition. And if it's an Elsevier product, even better. And then just make sure, which I can't say there'll be a problem, but the papers and the explanation that we give for why we're doing the special edition, that it has a geomorphological narrative. It's quite often overlooked, and so if we make it too quaternary in flavour, then they'll say, well, why aren't you just doing it with Quaternary International or one of the quaternary products? So it's quite geomorphology is very broad in scope, but that geomorphological context needs to be quite clear, I think. I'm happy to obviously to be named in some capacity with the proposal, and that can sometimes also help us as well.
Yeah, maybe I could add that the advantage of Quaternary would be that it is open access, and that's counterbalancing the author's fee. That's their policy. So it's up to FLAG, I think, to decide where to go.
Maybe we distribute these two options by email and collect the responses. Okay, maybe that will do. Okay.
Yeah, my proposition is that we first can start from the collection of the theme of these papers. Yeah, if we have this list of these papers, we can decide what we will be doing.
Okay, maybe we will have a long list, which will be enough for 2 special issues.
Yeah, maybe will be so many papers, yeah, for 2 issues, but
yeah.
Probably.
Of course, if Jeff managed to cancel the fee for us. Okay, let's do it. So after today evening, I will send through the email these 2 options and ask for responses. Yeah. Who would like to contribute then, and in which journal? Okay.
Can I just ask Martin something? Martin, is there's no sign that geomorphology is interested in going open access in the near future? I mean, Elsevier seems to be one of the slowest in that respect in terms of publishing.
Yeah, it's because Elsevier are the big bad wolf of the publishers, aren't they?
Well, if you think
they're probably just biding their time, hoping that it'll all go away. But you can slowly see that all these kind of broader publishing arrangements are now being negotiated at country or European level or something like that. So if anybody's going to lose out, it's probably the UK, actually, for our own stupidity of doing what we've recently done. But nothing concrete to say, really.
Yes.
I think that also for Quaternary, it will be necessary to have a proposed or a list of proposed contributions, and they also want to have an idea of the authors who intend to publish and the titles and a rough time schedule. Yeah.
Okay, so we'll all look out for emails about this then. That sounds good. I've got to go, folks, because I'm going out in the field, which seems something I haven't said very often lately, but only within the UK, and squeezing it in before teaching began. I really enjoyed this, so thanks very much for putting it on, all you guys who've done all the hard work, and it's been nice to see everyone. But please excuse me for now leaving. Cheerio.
Thank you, David. Well, so now we have decided what to do with special issues. So we will distribute information by email. And let me just maybe say a few final words on the conference. And well, Tomasz Probably you will also distribute the information on the options for the next flag meeting also by email, okay?
Yeah, okay.
What we have decided here. Well, at that meeting we had 33 participants from the westernmost country in terms of geographical coordinates was Peru and Brazil, and the easternmost Russia, and in between them many countries from Europe, west to east, UK, Portugal, Netherlands, France, Italy, Germany, Poland, and Romania. So you see that in this list there are now many continents such as North America, Australia, Asia, the continents with very well developed research in fluvial geomorphology and quaternary, and probably this is the perspective for involvement into the flag activity. That's to the flag board to think it over. Unfortunately, this session conveners had to be strict on the schedule and sometimes did not give the opportunity to ask questions after the talks. So we encourage participants to ask unasked questions by email. All addresses are available in the abstracts and also in the abstract book. As to the abstract book, it is ready, just waiting for ISBN number, which will take some time. And I have spread the draft of the abstract book by email. You will find it in your mailbox, just for checking the abstract titles, list of authors, and other more things. Not large corrections. I also want to ask, probably also by email, what we can do with the record of the conference. We have the full record, and we have 3 options: put it to the web for free access, second, to distribute between participants, and the third, not to distribute at all. So please, who would like to prohibit the public use of the presentations, against posting it to the internet or distributing amongst the participants, please write by the end of this week to the conference mail or to me personally. Maybe I will also spread it by email. Well, I also wish luck to Elon Musk with his project Starlink on providing the internet access to any point on the world, because we have seen at that conference that many of our colleagues had problems with internet access, and it seems that such online conferences will be more usual in the nearest future. So we need good internet access. So luck to Elon Musk and to all of us. Thank you for your participation in this meeting, and I hope to see you all not only online but also in person. Well, let me then close our meeting here. Oh, maybe anybody would like to say some words. Tomasz.
Yes, thank you very much, Andrei, for this meeting. It's very pity that it's only online, but I hope that we will meet in the future.
Sure.
Thank you for all contributors, for all papers, and I think my last question is this list of the papers we sent to you or to me, or where we collect these papers, and where will be this deadline for this?
Let us collect the list of papers and abstracts at the conference mailbox. Okay, it's usual for participants.
To you, yeah.
Yeah. Okay. And after that we will decide what to do. Okay.
Okay. Thank you very much.
Thank you much. Bye.
See you. Bye.
Thank you very much.
Bye.
Compliments, very good quality.
Thank you, Andrei.
Bye.
Nice to meet you all. Bye.
Yeah.